Hello, everyone. Welcome to the McDonald Observatory live stream, and actually a very special live stream. So today we actually have people from Lowell Observatory talking with us today to talk about Mars, and they have lots of really cool facts to share. We're really excited to have them here today. It's kind of one of our second joint live stream with them, actually. If ever any of y'all saw the lunar eclipse stream, if you haven't, it is on our YouTube channel. Yeah, for those of you old and new, welcome to our McDonald Observatory live stream. So my name is Saul Ribera. I'm one of the public program specialists here at the McDonald Observatory. So I do programs such as these, public programs, so guided tours and other jobs here and there. And also joining us today, we have Judy, Kevin, and John from Lowell Observatory, and Joe. And Judy, why don't you tell us a bit about yourself?
Oh, okay. I'm Judy Meyer, and I live and work here at McDonald Observatory, and I've been here for a very long while, and I get to do public programs, and also I'm a K-12 education coordinator, so I work with students and teachers, and we're getting ready for summer workshops, so lots of things on my plate.
Hi, Joe Wheelock. I work here too with Judy and Saul, public programs. And my sweater is not white. This is an infrared camera. And so my job tonight is to run our 16-inch telescope to look at Mars. So this is probably all that you'll see of me for the first couple of minutes. After that, I'll be behind the scenes. So we have nice clear skies here. Should get some good views of Mars.
Yeah, and also if his eyes look weird, do not worry. He is not a vampire.
Right.
That's really bad. It's just camera effects.
Right.
And yeah, Kevin and John, tell us a bit about yourselves.
Go ahead. What up, nerds? It's me, John Compton. I guess I work in the public programs here at Lowell Observatory. I do science communication and all sorts of other weird things. Just a big fan of geology and Mars and geophysics and things like that. Yeah, you might catch me on the Star Stuff podcast sometimes, or our interactive stargazing here.
And I'm Kevin Schindler. I'm the historian and public information officer here at Lowell. And I've worked here almost 28 years. And so I haven't got a pink slip yet. So I'm looking forward to the next year. I was in the public program for a long time and spent, I don't know how many nights at the old refractor where Percival Lowell did a lot of his work. And in fact, where we're sitting, we're less than 100 yards from his telescope. And right in between us is the mausoleum where he's entombed. And we're in his was his office from 1910 till he passed away. So we have Percival Lowell's spirit with us a little bit tonight.
Just gonna see him floating in the background.
There'll be a floating head back there somewhere.
Yeah, thank you so much for being here tonight. Yeah, so so before we continue, so if y'all have any questions throughout the program, any of the viewers have questions, feel free to drop them in the chat. We do have moderators on standby to answer those questions. If they can't answer them or they think it'll be cooler if one of us answer them, they'll be forwarded along to us. So feel free to drop those questions if you have them. And tonight we actually have some live views, not only from McDonald Observatory, but from Lowell as well. So I'm actually going to show us off really quick. So we're going to start with the Lowell Planewave telescope right now. So yeah, we got a live view of Mars.
And this telescope is part of what's called the Geological Open Deck Observatory. There's 6 telescopes inside of a building that looks like a hangar. The whole building rolls back, and you have an instant star party. And so it's really great for these kind of events.
Ooh, that's really cool. Yeah, let me bring up the live view from the McDonald Observatory. You can see we're right now seeing from our 16-inch telescope and one of our domes usually for public programs or live streams. And it is a bit later here, so it's a little bit darker, so you can see some other little details of Mars as well. And yeah, we'll be showing these live views throughout the night. And there's also the telescope Joe's on. So if you see anything weird going on with this telescope, then you can blame Joe. But yeah, to start off the night, what we're going to do is going to also not only show Mars, but talk a bit about it. So we each have some cool things to show off and cool things to talk about. But kind of to start off with Mars, I want to talk a little bit about, well, the numbers. So what is the Mars? What's like the rundown of the numbers, such as how far away is Mars? So Mars is about 1.5 AU. So 1 AU is about 1 astronomical unit, about 93 million miles away. So the distance between us and Earth. And Mars, apart from being a bit farther away from the sun, is also a bit smaller. Has a radius of about 2,100 miles across, which actually makes it about half the size of Earth. So here's actually a little thing of Earth per scale. So Mars is pretty small. Some other little cool things about Mars is that 1 day on Mars is about 25 Earth hours. So if you ever wish like you could have an extra hour in the day, just move over to Mars and that will happen naturally. And also Mars, with how small it is has a lot less gravity. It's about 30% of Earth's gravity. So also, if for the New Year's coming up, if you want to cheat your New Year's resolution of losing weight, you can move to Mars, and hey, that counts. That at least counts on the weight scale. Mars is also pretty cold, with an average temperature about 84 degrees Fahrenheit, or not 84 degrees Fahrenheit, 84 degrees below 0 Fahrenheit, negative 63 degrees Celsius. So for those of you up north, you're probably doing some training for Mars. And also another thing about Mars, apart from how cold it is, that makes it not so fun to live on, is its atmosphere. Its atmosphere is primarily about 96% carbon dioxide, a little less than 2% nitrogen, and a little bit less than 2% argon. And these are really cool numbers about Mars, but one of the cool things we want to talk about today is, well, as you saw from our little tile card, it's Mars opposition. But what does that actually mean? So to talk about the Mars opposition, I'm going to pass it over to Judy.
Okay. Well, what you're seeing on the screen now is a little animation, and you're seeing the Earth and Mars orbiting the sun. And the Earth orbits the sun, I'll bet you know this one, in 365 days and a little bit. And Mars orbits the sun. It takes longer. It's farther out. It takes longer to go around. It takes 687 days. So that's so Mars goes almost 2 times around in the time it takes Earth to go around once. So about every 2 years, the Earth, and you can see it on this video, the Earth kind of catches up with Mars, and Mars gets close to us. Now, Mars and the Earth got to their closest point last week, just last week. And Mars and the Earth tonight are doing what we call opposition, which is different from closest. And you might also notice that Mars's orbit is not quite a good circle and concentric with Earth's orbit. And Mars's orbit is what we call elliptical. It's a little bit of a squished circle. So you can see that sometimes Mars is closer to the sun, sometimes Mars is farther, and sometimes that means Mars is closer to the Earth, and sometimes Mars is farther. So let me switch over to a slide here. We just saw Mars catch up with the Earth catch up with Mars. And so what we're seeing here is the point that we call the closest approach. So Mars and the Earth hit their closest approach on either November 30th or December 1st, depending on how you count it. And that just means because of the shapes of those two orbits, they were nice and close. And I think there should be an arrow growing in, but it doesn't seem to want to do that because it hates me. Let me just try that way. All right, there's the arrow. So at the closest approach, Mars and the Earth were 0.544 AU apart. And Sewell said AU, and I'm saying AU. And an AU, I will tell you, is an astronomical unit. And that's the average Earth-Sun distance. So it's something that works really well for those of us who talk about AUs all the time. But most humans don't, I realize. And so at closest approach, Mars was 50,614,000 plus or minus some miles, and that's 81 million and a half or so kilometers from the Earth. So 50 million plus at closest approach, okay? Miles. Now, you might have heard maybe 2003. In 2003, Mars and the Earth got really close. So the closest approach happened just over here where Mars's orbit is very close to the Earth's orbit. And at that time, it was only 35 million miles away from us. So that was way closer. And this is a pretty close approach. And so some years it's closer and some years it's farther. So that was last week. This week and today, we're at what we call opposition. Now, opposition just means that we're Earth-centered, right? Because we live on the Earth, and we're, what do I want to say? We're self-centered, and opposition means Mars and the sun are opposite each other from the Earth. So let me draw in that line. I hope this works. There it is. So Mars, the Earth, and the sun are all in a straight line. And what that means for us here on the Earth is that as the sun sets in the west, Mars rises in the east. So I saw someone in the chat asking when Mars was going to rise, and Mars is at opposition. So that means as the sun set, Mars will rise. You also might have heard that last night, for some observers, Mars was going behind the moon for our view. And raise your hand if you saw that. Saul, did you see that?
Nope.
No. John and Kevin, did you see that?
No, we had some pretty healthy clouds last night.
We had healthy clouds that were raining on us last night. So some people saw that, and some people in the chat are saying they saw that, and that's really cool. And that just means the moon, and full moon is when the moon is opposite the sun compared to the Earth. So the moon and Mars are pretty much on opposite sides of the Earth, and that means the moon and Mars, just because of the way their orbits work this time around, the Mars went behind the moon for lots of us, especially in North America. So those are the things about the orbits that I want to talk about. And now it's time to pass it over to, I forget, Lowell Observatory. So thank you.
Well, great. Thanks. Again, it's really great to be with you guys and gals. And, you know, Mars is the reason Lowell Observatory is here initially, because our founder, Percival Lowell, he got really interested in the planet and the idea that there might be intelligent life there. And he wanted to prove this. And he founded the observatory in 1894, 18 years before Arizona was even a state. And so the place has been here a while. And you can't come here without thinking Mars, because the mesa that we're on, we're about a mile west of downtown Flagstaff. It's nicknamed Mars Hill. And when you drive up to the visitor center at the observatory, right in front of the visitor center is this big sphere, and it's actually recycled art. It's a propane tank that's circular, made years ago by local artists, and and they made Mars. And so it's got the Tharsis volcanoes and Valles Marineris. And if you look through, it's also a kaleidoscope. And so you look through and spin it around, and so you can't come up here without having some awareness about Mars. And then, of course, our founder, Percival Lowell, like we said, we're sitting right where in his later life he was doing some of his writings. Like we have a couple of books right behind me here. He wrote several on the planet Mars. And, you know, we look back, and a lot of his ideas we know were just plain wrong. And yet it's so compelling because he gave such a interesting case, and made it really provocative. Is there life out there, and what's it like? And he really inspired people and created this consciousness of life in the universe. And so as we talk tonight about Mars, and if we talk about not just the science, but the cultural side of things, science fiction, writers like H.G. Wells and Edgar Rice Burroughs, they wrote books based on, just like writers today write about things that are happening right now. Well, back then, Percival Lowell built this consciousness that there's life out there. And so that's what they wrote about. And so Lowell had such an impact on the science, inspired people like Carl Sagan, and also the culture. And it's a magical time to talk about it for us, because we're right in the middle of where Mars has been at the center of attention for, gosh, whatever, 130 years. And today we still have astronomers here, Jennifer Hanley, for instance, who I think is giving a talk or just finished a talk down in our visitor center about her research on Mars, looking at salts of Mars. So it's really quite a legacy here. And one of the neat things here also is when Percival Lowell was writing about Mars and imagining what it would be like there, he looked across where we're sitting right now and saw the plains of Arizona, the red rocks. I'm looking toward the painted desert, and he saw Earth, but imagined Mars, as historian Mike Amundsen has said. And a lot of his writings were inspired by what he saw here. And the geology isn't necessarily the same, but the look of it is. And John can talk a little bit about that geology and how it compares and what it's like there.
Yeah, and even kind of what you were saying about we've been studying Mars for a long time, and we still do. Like even E.C. Slipher's work with photographing Mars and sort of like showing that Mars had an atmosphere with really, really early like astrophotography and things like that. It's really, really cool. I love that stuff.
And in fact, you mentioned E.C. Slipher, two brothers that worked here, and E.C. Slipher kind of inherited the Mars ownership from Percival Lowell, and he took the first color image of Mars. He took 3 expeditions to South Africa to do some of his research. But one of the neat things he did while doing this imaging was what we know today as stacking images. It was some of the first image stacking done anywhere, and now today it's a standard that we use in astronomy. So there's a lot of connections of Mars here. That's really fascinating.
Yeah, they were going hard to document that we had that Mars had an atmosphere and to take those early images. One of them was up here taking photographs through probably up to Clark, and one of them was down in Bloemfontein in South Africa taking pictures. We had basically 24-hour coverage of Mars. It was really, really neat. But yeah, Flagstaff's a really cool place for sort of like lunar research as well as Martian research. Yeah. We have a very martial geology, I guess. Mars is mostly basalt, right? And basalt is just, it's sort of an igneous rock. It's everywhere. It's all over the place up here at Lowell Observatory, or all over Flagstaff and this part of the Southwest in general. And it's kind of partially why Mars looks so red, right? It's a lot of the oxidized iron and oxidized materials. But you could sort of imagine like if you took the Shield volcano or took all of Hawaii realistically and just waited a while, it would start to look a lot like Mars.
Wow.
Lost all the water because it's that really really smooth flowing lava type that makes these really, really not tall but very, very wide volcanic features and things. Mars isn't super geologically active now anymore. It's cooled down quite a bit. We still think it has a semi-liquid core to it, but that's mostly just from pressure. It doesn't really have a sort of dynamic mantle at all, so nothing's going on between the core and the top. So it's pretty still. So realistically all the cratering we see on the surface is kind of come from the time that it's kind of stopped doing things. But yeah, we see a lot of old sort of like riverbed features and things. We see a lot of volcanoes, and we do see a fair amount of stratigraphy. We see like different layers of deposition forming. A lot of these like delta layers, like you'd imagine around like Louisiana, kind of like the stuff coming off the river, forming these really cool fan motions. We see those preserved pretty well. But like when you think of basalt, I guess, I don't know, maybe you don't think much about basalt, like I do. But basalt tends to have a lot of this really green, really cool looking mineral in it called olivine. It's very bright, really pretty looking. And if you go up here and you just crack open some basalt with a hammer that you have lying around, you can find plenty of it, especially up near what's called the Naval Precision Optical Interferometer up here at Anderson Mesa. You see quite a bit of it in the basalt around there. And we know that Mars also has really, really olivine-rich basalts. And they weather pretty quickly. They'll turn into like clays and things really, really quick. So a lot of the surface of Mars is very, very fine. Like when you think about the surface of the moon, right? The moon is also basically just basalt and some other like felsic materials, but it's basically basalt. But the surface of the moon is really sharp. It's abrasive. Because there's no atmosphere, right? There's nothing to like tumble the edges off like when you were a kid and you put rocks in like a little tumbler with the sand and stuff. It would kind of wear the edges off and smooth them out. The moon doesn't have that, but Mars did. And so the surface of Mars is really, really dusty like that. It's very talc-like, like baby powder. And it's a lot of these oxidized, oxidized particles. And all the sedimentary rocks are made of the same sorts of things. When you weather that kind of rock, it gets that red color in the presence of water and stuff like that. And then you get the layers. So up here on the up on the hill, right, of Flagstaff, it's a lot of what Mars used to look like in the past. And then you go down to like Sedona, the Red Rock Desert, and it's very much what Mars is like now. And so you kind of get the best of both worlds with Mars, like past and present, and you get to see like this cool transition. I love the rocks of Mars, and I love the geology of Mars. Olympus Mons is awesome. It's this huge volcano. But because it's that shield volcano, because it flows really easily, it's not like a big, doesn't shoot up like a mountain. It kind of just bubbles out and streams out like in Hawaii. You could hike it like your car would drive up it. It would take a long time. The things
doesn't like go like above like the atmosphere almost with how high up it is.
You could like drive your car into space. Like when Mars, like when Mars had an atmosphere, right? You could drive your car into outer space because it's like a 1 to 10 ratio incline. So it's like this steep. Like you could drive your car up that. It would take it a long time.
Yeah.
You could hike it. Olympus Mons is like the size of Arizona, I think. Yeah, like in diameter. So it's huge. Like, but you could make a day trip. You could make like a weekend trip out of it. That's kind of fun.
I know there's lots of people that will definitely be up for that.
Yeah. I guess for liability, it is not recommended that you drive your car in outer space.
Yeah, do not do it. Elon Musk might have launched his car into outer space, but we definitely should try driving up that.
You need a secondary oxygen source. I don't know. You figure it out. Kids watching the stream, figure out how to do it and have cars on Mars one day.
Yeah, y'all will probably be the ones to be able to do that.
It'll be great. But yeah, I love the really cool weird features of Mars, like where you're like Mariner Valley. It's like this huge river. It's like it makes the Grand Canyon look like a little cat scratch. Like the thing is crazy. It goes basically from New York to LA and then some, like in length. It's incredibly deep, but it's also, even at its, like when you're thinking about the narrow side, like if you were to cross a river, that's still so far apart that the walls of the canyon go beyond the horizon from your view, which is crazy to think about. Like just this incredible features. So feel free to drive your car through that, I guess. Yeah,
I'm trying to picture that. That's like ridiculous. It's so cool.
It's deep. It's a deep canyon and some deep thoughts.
Hey, John.
Yeah.
There was a comment in the chat a while back, and I am going to put it up here. It said, a paper just came out this week claiming they identified an active mantle plume on Mars.
Oh, that's awesome. That's really cool. I've got to check that out.
That's from our friend Kent Colbeth.
Oh, nice. Thank you so much. Wow, that's really, really cool.
Okay. So I'm glad you know that now. What does that mean to humans who don't know what those are?
Sorry?
What does that mean?
Oh, so you think about like the convective cells and advective cells inside the mantle. So the mantle is obviously it's the part beneath the crust, right? And beyond the core, it's that little gap in there. And here on Earth, it moves around a lot, right? From heat, and then things cool. You imagine like the classic examples, like think of a lava lamp, where it kind of like bubbles up and then it cools down, so it goes back. And we have like these huge subductions, and it's where we get like tectonic plates and things. And so it's got to be pretty hot to do it, to keep this stuff like that ductile for long enough to be able to like flow like Play-Doh or clay or whatever. Not really. It's a lot harder than that. But to have it be able to move around, you need things to be pretty hot. And so the fact that it's still moving around is really cool. Just because Mars is at least surface-wise, I believe it's geologically inactive. But this means that we could see something long-term or like a much larger scales. I feel like there's a lot of really, just from this paper, I feel like there's going to be a lot of really cool follow-up studies on, we've got like the Mars reconnaissance orbiter, things like that, sort of like imaging the surface. So what does that look like long-term? Are we going to see that there are actually some motion, little bits of mass motion and things like that aren't connected to just regular CO2 atmosphere and dry ice and things like that. That's really rad. Mars Reconnaissance Orbiter. Whenever I see it written, I think it says Mars Renaissance Orbiter.
Which it sort of is.
Yeah, right.
Ye old orbiter.
That's really cool. Yeah, mantle works like my jam. That means we need to get some seismometers up on Mars. Get in the seismometer. Sorry.
Don't we have some?
Oh, we need to blast it with them though. we got to cover it. Like there was that big United States one where they had the giant grid that went all across the United States with seismometers. We did the same thing, just cover Mars in seismometers. So future jobs, planning seismometers, y'all.
Yeah, with Mars being smaller, it will be get so much more area covered.
It'll be so easy. We'll get it done in a weekend. We'll go up for
yeah. Everyone just pick one up and just put it in your Martian backyard and get it covered.
Cody Half Moon, I do not want to blow up Mars. I want to hit Mars with a hammer and then see what's inside of it. But that's the geologist in me. That's like what we do with the things we love.
Yeah. Though actually I had kind of like a question, like how much similar is like Earth's layout, like with a crust, mantle, core, how does that compare to like Mars? Or are like very similar, very different, just with like Mars not being as active as Earth?
Well, so Mars is fully differentiated in that we do have all of the sort of minerals and rocks and things that went to their different zones. The light stuff floats to the top and the heavy stuff sinks to the bottom. We have all the layers that we would expect. It's just obviously a smaller scale. It's a terrestrial planet, so very similar to Earth, and mostly the same sorts of stuff. I don't think there's nearly as much like of certain rock types. I don't think we have nearly as many like pyroxenes. I don't think we have nearly as many like feldspars. Because it's the planet as a whole is generally way more iron by like ratio than Earth, right? Which is why it's so red, right? There's like an anecdote here at the observatory that Sarah always talks about, like why are barns red? And the answer is because like red paint was easy to make because of rust, and iron is very, very common in the universe, so it's like very easy to make red paint to dye things red. Mars got a lot of that red paint, right? The core is way more iron than like magnesium as far as the ratio is concerned here on Earth, and same with the surface. But in general, it's been fully differentiated, right? We've got the different zones and the zones we'd expect them to be. Right?
Cool.
And Mars would have been very, very Earth-like at some point. We know there's these fluvial deposits. We know it had riverbeds and things like that, and like deltas, and one would assume lakes and things. Now it's enough to have all these sedimentary deposits everywhere for sure, that we can see. And this is what happens when you lose your atmosphere, right? Things kind of stall out. You lose your protective sources, and things kind of just hit this little relaxing Martian retirement, where now it's just a beautiful, cool red planet.
Nice. Yeah, I know there's like a lot more questions, like how comparably is like Mars and Earth, especially now it's like more hype about like possibly sending people there and such. That's a question that
Well,
that's one of the reasons why for so long it was thought there might be life there, because it did look similar. And in fact, Percival Lowell, when he talked about there being life there, it was more than just the supposed canals he saw. He believed in this theory about how planets were formed. If we go back to the 1800s, in 1859, Charles Darwin came out with a theory of evolution, which was biological stuff. But then scientists and economists and others tried to adapt that to their field. And so a fellow named Herbert Spencer came up with this idea that of cosmic evolution, that things like planets evolve to where you have planets are formed out of these big gas balls, and then over time solidify. Some of the gas goes away, but there's still some. You have an atmosphere, and then eventually no atmosphere is a dried up prune, as it were. And in that theme, you have Saturn and Jupiter are young, Earth and Mars are middle age, and Mercury is all dried out. Well, for him, Mars is in the right stage of evolution. It's got the atmosphere and these features that appear that they were artificial, and so that there must be some sort of life there. So he really, his idea of it was because it was so similar looking to Earth. Of course, as John is saying, it's not as much as you can say just by looking at a fuzzy thing like we see here and looking at this over and over every night and imagining if there's a civilization there. For us, that feels like a leap of faith. But that was the comparison being made. It's always had that it's a close neighbor, and if there's life out there, it's probably right there. And so it, even into the 1950s, when the Mariner, and 60s, when the Mariner missions finally arrived at Mars, even up until then, there were still some people holding out. Maybe there are canals there of some sort. It's this. We all think about it. Is there life out there? Are we alone? And it gets to that. Of course, we don't know for sure. It hasn't been proven conclusively there's no life there, or hasn't been. There is still conceivable, but it's just the planet is part of our, our scientific makeup. Like here in Arizona, we have 3 state universities: Northern Arizona University here in Flagstaff, Arizona State in Phoenix, and University of Arizona in Tucson. And all 3 have major Mars research. U.S. Geological Survey here in town. It's just such a big focus of research. And then, like we're saying, the cultural part, this imagining that maybe there's life out there, and when the red planet comes up, that's it. That's where it could be. And we tie in some things like the War of the Worlds and Orson Welles' radio broadcasts in 1938, where it sounded like it was a real broadcast. We're being attacked based on H.G. Wells' War of the Worlds book. It just is this compelling idea that it's almost like, inside we want it to happen. Yeah. We want something to be out there. And so if there's any evidence, like in the late 90s, when they found the Martian meteorite that was recovered from Antarctica, and it looked like it might have structure that looked like some sort of fossilized life, and scientists quickly showed that there were other answers for it. But the day after that announcement was made, could be life on Mars, one of our staff went to the mausoleum, Percival Lowell's mausoleum, and there's a glass of champagne and a cigar, because he likes cigars and champagne, and this note that essentially said, "See, you were right all along." So it was, I think it's that makes it, it's the science on its own is so fascinating, but then you put in that human element, and it really Mars really, captures our imagination in so many ways.
Yeah, the curiosity, like even like the books, and such, like Red Mars, Green Mars, Blue Mars, and also not to mention now the Martian, and just it appearing again and just media. Yeah, it's just the
And
fascination.
and a lot of science fiction, I mean, is based on, like you were mentioning the red, green, blue Mars or whatever the order is, um, and the idea of terraforming Mars. And it sounds so science fiction-y, and it takes a long time, but it's fascinating to think about, could we do this over time? And so, so much of the science fiction reflects what the scientific community is thinking at the time.
And you have like some like the really out, well, like one of like the methods. I think I could be wrong, but I think it was Elon Musk about like, oh, like the terraform Mars, nuke it, hope that increase the temperature on it, and once the nuclear radiation kind of calms down, we should then inhabit it, or it backfires and just do ice age on Mars.
So I'm sitting here and I'm looking at this image of Mars on my screen, and I'm wondering how someone could have thought that was canals.
Well, it's interesting because Percival Lowell wasn't the only one to see these supposed features. Going back to 1877, when Mars made an exceptionally close approach to Earth, that's the year that Asaph Hall discovered Mars's 2 moons from the Naval Observatory in DC, and also the year that an Italian astronomer named Giovanni Schiaparelli kind of mapped out these features he called canali. He wasn't the first one to use that term, but they looked pretty linear, not natural. And Percival Lowell wasn't the first person to see the supposed canals. He wasn't the first person to suggest they indicated life, but he was the loudest for sure. But yeah, if we look at it, and it's like a lot of things, like we look at this, and this is one view of it on one night, and the seeing is, it's not exquisite, but the view he had was so tiny. But looking at it over time, night after night after night, it is hard to imagine. And there's some moments where it's exceptionally good, and you see different faces of it. And sometimes when you see the polar ice caps, they're very distinct. You can see them. But to think that tiny little thing he was seeing through there, he was seeing, not just this network that he thought were canals, but creating this entire, idea of life on Mars based on that, and how it worked, and that they dug the canals to bring water from the ice caps to the dying nation, and these little oases connecting the lines were centers of town, as it were. There's a lot, and yet, I think one of the interesting things is Lowell wasn't a crackpot. I mean, he was a very brilliant person. His professor at Harvard, Benjamin Pierce, said he was the best student he ever had, and so I think that's part of the interesting story. It's just not this this wacky person that has been living alone too long, and has these ideas. It's I mean, he made it sound so good, and it did sound good, but there are a lot of assumptions that he made. But yeah, getting back to your question, how could he see all these canals? One of the things he did was reduce the amount of light coming into the telescope, stopping it down, and he played with that a lot, to where he could, imagine these lines. And it's been suggested, some people have said it's an optical aberration, like, there's some, points here and there, but our eyes tend to connect the dots. Others have suggested he and others were seeing reflections of, structures in their eye, but it's not something like we saw at the telescope and say, oh, there they are. Yeah. And what's interesting is that I think it was around 1906 when they were really starting to get good at taking pictures. One of the scientists here won an award for capturing the canals in pictures, which he didn't do, and yet he won an award for this. I mean, it's you see what you want to see sometimes. I mean, it's interesting. Again, I think this is part of the interesting part of it. The science itself is fascinating, but because it gets into this idea: is there life out there, and how could they imagine it was there? And holy cow, that's like a fuzzy little dot. How could he imagine waterways and all this? It really, again, captures our imagination, I think.
But to see it through the Clark, occasionally we'll have times where we can look at Mars through the Clark, and on a really cold, really clear night, where with really good seeing, I can imagine some stuff. Like this much whimsy and a good view of the night,
And some wine.
Who's to say?
And a cigar.
Yeah,
That's right.
Yeah, for those of you who don't know, that telescope is a lot bigger than the one we have for the live views right now.
Right, and it looks like our moderators have been chatting about, yeah, we see a feature that looks kind of linear on the image of Mars, and if you have a bigger telescope and Mars is higher in the sky, I'm sure you could find things to look a little sharper.
Let me grab Mars here. This is a reproduction of one of Lowell's Mars globes. I think this will show up, hopefully.
Yeah, there.
Let's see, I gotta make you bigger. Let's see, bring you to the front.
To the front.
There it goes.
Okay, I'm not sure if that, and so you can see the latitude, longitude lines, but you see all these linear features. I mean, it's an entire network of these things. This is from one of the oppositions, and so like when we're looking at that live view of Mars, it does look like the edge of that darker area is straight, but look at this. It's like this spider web network of things that he saw, and seeing all that on that little tiny dot, because looking through the big telescope, it's still tiny. It's just not very big. a lot of the planet. So it makes you wonder. But that's why the modern science is so great. The USGS here in town has done so much mapping of Mars, and then all the spacecraft that have been there. The Mariners through the Vikings and Pathfinder in the 90s, which was spectacular, and sending the rover out there, Sojourner, and all the rovers we have now, we're finding out so much about it. And as John said, all these features that it looks like there was a lot more water at one time, which can make sense, and it makes sense why there's not now, because atmospheric pressure and such. But it shows the progress of science. I think Mars is great for that, because what do we know about Mars? At one time, people at some point looked up and noticed this bright dot that sometimes was a little orangish color, and eventually they called it a planet because the planet is wandering across the sky, and they could see how it orbits and how it goes retrograde. It seems to go backwards, but then we get telescopes and we can look at it up close, sort of. But then we send spacecraft out there. We fly by it and get a quick view. Then we send orbiters, and we can see a lot of different sides of it. But then we land there and can collect materials and analyze it chemically. It's really great, and shows how science progresses from, we know a little bit, we come up with ideas, we learn more, we modify our understanding, and it's, science is a progress report based on the current knowledge. And the study of Mars, I think, is a perfect example of that, how our ideas have changed and, narrowed down over time.
Yeah.
So really quick, kind of going back to pulling Mars to the sky. So one of the common questions that's been coming up in chat is exactly, where is Mars in the sky right now? It's what part of the sky it's in? So it's over there. So to share that, I have this little software here, Stellarium. So should be able to see my screen. Let me pull that up. There it goes. So by the way, this is a free software, but free on Mac, Windows, and Linux. And so if you're wondering where Mars is, so here we got the moon here in the center. And kind of to the top right, you see kind of like a reddish, orangish star, rust-colored star that's not twinkling. And that one is Mars. So if you are in the clear part of this, or if it's clear where you are and you want to go outside and give it a look, this is where it's located.
Oh.
And it's the brightest thing up there right now.
Well, the moon.
Eastern sky. Yeah, not counting the moon.
How
Yeah,
far is it from the moon?
It is. I don't know the distance, so this far. Don't know the actual
That far.
numbers.
Thank you.
About
That far.
you say about a fist width.
Yeah. So yeah, about a fist width.
Yeah,
That-
the
that's
moon
what
has
it's gonna be.
moves what 15 degrees every night or whatever. So the distance it moves since last night when it was so cold and by it. So that's actually interesting because you can see from that about how far the moon moves every night. Where Mars is, that's how far the moon moved from last night. And so every night it changes that much.
So our moderator is saying 10 to 12 degrees, which is about the width of your fist.
Yeah.
Haha, nailed it.
Yeah.
One.
Well, actually, John, a question came in that I think will fit your expertise from Teresa Anderson. So it's kind of going back to the paper about the mantle plume. Would this mantle plume knowledge in the paper be around one of the lava tubes on Mars?
I have not read this paper. I believe it's probably evidenced by a very large scale geologic feature. They're probably looking at something in a very large region and seeing changes in it to detect the mantle plume underneath. I have not read the paper. This is just a guess. And so there's probably tons of lava tubes all over that zone. Sorry, yeah, I would guess just based on statistics, it's likely, but I don't know for sure. Sorry.
Yeah, no worries. I think it's more like you are like the one who will have the best educated guess out of us here.
Yeah. Rocks and mythology, that's what I'm good for. Yeah. The lava tubes are really cool though. We have similar lava tubes up here in Flagstaff that are a fun tourist attraction. It's just like when lava tubes kind of breach the surface when it's really slippery, really hot. Magma coming up and the lava flows, and eventually they'll just collapse because they turn very, very brittle when they cool. And then you can see exactly where things float underneath the surface. It's really fun.
Yeah, there's one by Sunset Crater, which is one of the youngest volcanic areas in northern Arizona. We're talking like 1,000 years.
Mm-hmm.
But then north of town, there's one, you go underground and it's about half a mile, and you can walk upright through most of it. You have to kind of crawl through some of it, but you can really see the flow. And it's like, if you can see more recent ones in Hawaii, but you can imagine this thing happening on other places like Mars. And so the analogies on Earth make it really useful for understanding what's happening elsewhere.
Oh, so a question has come, and I think it's supposed to be directed at all of us, such as what we believe on it, from Charlie, and I believe, apologies if I mispronounced the last name, Andrej. Should Mars samples be returned to Earth? I'm guessing if that's like, if we think they should come back here or not. I'm gonna assume his question is relating to like cross-contamination, or if there's like a secret thing on the Mars surface that can affect
Yeah, we're
us.
not allowed to
That's
talk
gonna be
about
my
it.
guess.
We can't talk about it. We're not allowed to.
The answer is yes. Yes,
Yeah,
Mars samples should be returned to Earth so we can see them.
From a scientific standpoint, the more we can learn about Mars, the more we understand our origins, our solar system, ourselves. And, just like when we went to the moon, there were concerns, will we bring space bugs back, as it were, bring contaminants back, or will we take contaminants there? I mean, that's something you build into it, but if we have the opportunity to bring rocks back, yes.
Yeah.
That's how we learn. And, that's what we did with the moon. The moon is just closer, but we're now getting to the point with Artemis. Ideally, in the next couple of years, Artemis will take people to the moon in orbit and then actually land again. And there's always a question, it costs so much to send people there. You can do a lot more robotic research, but there's that human quest to discover. And when the astronauts walked on the moon, they didn't walk along. There were millions of people around the world walking with them and discovering and exploring with them. And that human spirit of exploration you can't put a price tag on it, I don't think. And so,
Yeah.
just like that, we brought rocks back from the moon. Once we can do it for Mars, let's do it, because Artemis, one of its long-term goals is perhaps to send humans out there. And if we have that capability, my opinion is we're foolish to not to take advantage of it and go explore. That's who we are. And it inspires future generations to want to learn more.
Don't we have Martian meteorites here
Yeah.
on Earth? So like we've got, and it hasn't ruined the Earth yet. Like, I think the big concern is the other way around, right? Contaminating Mars. There's a lot of places on Mars where, we look at very extreme conditions on Earth and say like, oh, nothing could live there. And then it's like, oh, look, there's this microbe that's doing just fine. And if that were to get to Mars, it would be like a vacation day. Like I could take it easy on Mars, that's the kind of stuff that we got to worry about. So, just like sanitize your hands before you touch the Martian soil, kids,
Yeah, there's already like missions like all around the world of like the whole thing of wanting to go to Mars, wanting to like Japan has several. It has one called Terex, which is sending some like a satellite that basically is using like a terahertz sensor to like see how this conversion rate. And actually one of their missions in 2020, let's see, I think it's 2025, called Martian Moons Exploration. It's actually being sent to Phobos, going to collect samples from Phobos, and also check out the other moons and come back. And it's like also the Indian Space Research Organization, Japanese Space Agency, JAXA, Canadian Space Agency, Italian Space Agency. They're all working either on their own or with NASA to like get all this stuff. It's really exciting.
Really cool.
Like, I geek out, but like for me, I personally won't go to Mars. I don't want to go and live on there, but I'm really excited to see like, oh, we're going to learn from that. And
you think about, it's been 50 years since humans walked on another body in space. Apollo 17 is 50 years ago, like right now, today, that it was on the moon, and we stopped, and now finally 50 years later. We're developing the technology to go back. Of course, all the uncrewed missions that we're learning so much about, that combination of uncrewed and crewed missions, I think is going to inspire so many future generations of kids to want to go into science. And even if they don't go into it, to be more aware and to look up, instead of staring at our phones all the time, look up once in a while and really get connected with the universe. And exploring like this, and the cover of magazines with these really cool pictures, it really gets people jazzed up. When New Horizons flew by Pluto in 2015, and we saw, what used to be a dot is now a world. That inspired so many people, and to see kids get jazzed about science and want to go into it and explore, I think it's the goal of all of us. Who do any sort of education, science education, is to not inspire everybody, but hopefully future generations see why it's so exciting and want to do it.
yeah, like I'm pretty sure y'all have seen it as well, but at least like here at the observatory, I have seen like people just get so much more hyped and interested in space with like the SpaceX, then Gene Flip Space Telescope, and now Artemis, and then future Mars missions. It's just like the interest is ramping back up again.
Yeah, it feels like we're entering another golden era of space exploration.
I really hope so. Can't wait. Actually, there's a guy here that a couple weeks ago, one of our programs actually said his son-in-law is working with Artemis and such about like the restrooms there, how to make it, and then like other people are like, oh, that sounds so cool, or little kids are asking more facts, and like just they know so much more and are wanting to like, oh, I want to go to Mars. I think actually last weekend there's a little girl at the Star Party that was talking about how she wanted to be one of the people that goes to Mars and like grow plants there and kind of learn more about it. And she could have been older than 8, so she might be one of the ones to go there.
Just a couple months ago, NASA, they have a group called Desert Rats, and they're developing technology for future missions. And they had a couple of the rovers and are testing other equipment not far from where we are here, I don't know, 20 miles or so. And it's in this very alien-like landscapes as they're doing it. And it's where they trained for the Apollo missions, kind of some of the same areas. And I thought NASA did so great with it because they're not only doing this work, but they had a media day, but also brought out bus loads of kids to be able to see, what they're doing now, and they're going to be able to watch these people on the moon shortly, and hopefully one day on Mars. And so it's really great to be able to make it accessible like that. That's one of the great things about the internet and connectivity, that so many people can follow what's happening.
So cool. I didn't even hear about that. That sounds so cool.
I got to ride in the rover. It was really cool.
They look really neat.
I couldn't drive it. They didn't let me drive it, but I was okay because I got to ride in it.
Yeah.
And it's like, I think 12-wheel drive.
Yeah.
It's got 12 wheels, and it articulates, and it's really pretty neat. And to see it, I don't know, for me to see it with the San Francisco peaks, kind of the dominant geographic feature around here, in the background, and to imagine that those astronauts who walked on the moon were doing some of the same thing right where we're standing, and we're going back again. And it was exciting then, but now, males, females, different countries were involved. It's something that really, I think, is going to be more global when we go back now.
Mm-hmm. I have a quick question for Joe. Joe, the question is north up in our image of Mars?
I'm not sure. I was looking at that question, trying to figure it out.
Okay. Because it does kind of match the Mars map that I have on my app.
Okay.
That has north up. So I'm going to say it is. But
I will agree with you.
Okay. Well, good thing with space, up, down.
Well, the reason it could be different is because, telescopes,
right,
sometimes they flip the image and mirror reverse it. Yeah. So, it's okay. I'll agree with you, Judy.
How about the Lowell feed? Is north up in the Lowell feed?
I'm not sure if our Lowell folks are online there.
Okay, so
I'm not sure without seeing what the current, orientation of Mars is, because if we have that, we could line it up, but I don't have that offhand.
Yeah, it's
and is it tilted right now? Because on the McDonald image, you could almost imagine the ice cap to the upper right, but that might just be my imagining and wanting it to be there.
Yeah, it looks like there is. Yeah, I see that as well. It looks like there wants to be like a little. Yeah. I'm not sure if it's. I want to say yes, just because it does look brighter up there than the other corners, which would be really cool if that's the case.
Yeah, we just don't have what the current face of Mars looks like here, but we can look that up, and I want to look that up now. Yeah, you can. It really looks like there's a bit, but at certain times when the ice caps, they're really distinct, and there's no question about it, depending on, again, the orientation of the planet to us.
Okay.
And the type and the time of year also, because the ice caps expand and contract with seasons.
Yeah, it's probably on the contracting phase. I'm like squinting, see if that improves.
If we had Percival Lowell here, he would probably point out, a lot of features here.
I was going to say, everyone was like, oh, how come Percival Lowell saw canals? Here we are debating exactly all the things we could see on the surface by squinting really, really hard.
Just see with Mausoleum being nearby, see if he can summon his ghost to enter into the stream and point out the feature.
I thought I heard a scratching at the window just a minute ago. Just be imagining.
I don't know. That might be a zombie. I don't know if that's the one you want to open for.
I love it. Yeah, there's plenty of work going on with.
Well, we're just really pleased that after here last night with some clouds to be able to get some views of it. When I came in, the sky was pretty darn clear.
Yeah, we really looked out.
We're going to have snow, I think, in a couple days again.
Mm-hmm.
Oh wow!
Monday, last I saw, we're supposed to get 7 inches on Monday.
We currently have a frosty dome, so.
Ooh.
Yeah, the
Well-
dome has two ice cap.
What I'd like to say is before we talk too much more about the local weather, maybe there's more questions in the chat. How about, is Mars brightest when it is closest a week or so ago, or when it is at opposition, which is now? I don't know. It's about the same.
I would say closest.
Yeah.
Be my guess.
Yeah.
Like with Venus, the trade-off between closeness and how and what phase it's in kind of balances, which means it would have to be brighter when it's closest to balance out the phase. Yeah. Okay.
Yeah, that sounds right.
Okay. So it was brighter last week, but not by much.
Yeah, for us, if you're going outside looking with your naked eye, it looks the same.
But you don't want like a washed out, like a blown out Mars. You want like a little bit of. You want to be able to see some contrast a little bit. You want to see some fun stuff.
Yeah.
Like when the moon is full, it's boring looking. Because it's so bright. What are you gonna see?
Yeah. With kind of like earlier, like we don't want to blow up Mars, but sometimes we want to blow up the moon just because it doesn't make Mars as nice to look at.
Blow out. Talking about photography, not no.
Oh yeah, exactly.
No
Yeah,
explosives.
blow out. That is definitely what I meant.
Yeah, Mars
So
is
we're-
here now, which
yes.
makes it kind of interesting because it's near a bunch of other reddish yellow looking things.
Yeah, and then even like if it by chance goes to Scorpio, at least we have Antares, not
Yeah,
Mars, to
not Mars.
differentiate the two.
Yeah.
So, John, here's I'm picking the wrong question. Here's a question from Victory. Why does it seem like I see some dark shading in some areas through my telescope?
Probably some interesting features.
And what are
little-
they?
Let's say a little bit of contrast. I couldn't tell you offhand. These are probably going to be darker basaltic areas. Less covered with like that sort of talc, less covered with that. They call it soil, but it's not soil. It's just the surface dusting on Mars. These are going to be areas that don't necessarily have that as much. We're not going to be getting any sort of like phases of the moon, and we're not going to be getting any stuff where the sunlight's hitting it at an angle and we can see features cast in shadows, just because of like how far away Mars is and where the sun is right now. We're basically getting a full Mars or close to it. So they're probably just these darker basaltic flows. They would be unweathered or not as weathered. So like I guess more like below the surface. Mars does have winds and things that pass across it, and so like you can uncover areas that haven't been oxidized and haven't been weathered by like radiation, things like that. So probably getting some of those. I couldn't tell you offhand exactly what feature it is though.
And also it's interesting that like John was saying, there's some pretty heavy winds. There's some pretty substantial dust storms there, and so like when they were sending one of the Mariner missions up there, they were getting close, and they couldn't see the surface because there was a big dust storm going on, and so that's going to change our view a little bit also.
Yeah.
And throughout history, astronomers have looked and seen how sometimes what looks kind of greenish to those areas expand and contract. Historically, some people thought that was vegetation.
Yeah.
For instance, but that relates to the dust storms.
For a long time, even in like the 60s, they thought it was light, or a lot of people held on that it could be lichen growing on the rocks. It's kind of cool.
Well, I think it was the last time Mars got close to us. So the last time around, it seemed like there was a dust storm most of the time we were trying to look at Mars.
Yeah.
Yeah.
We basically didn't see much of anything on Mars.
There's not much we can do from here. There's no filter that can see through dust.
Yeah.
So you're just kind of stuck with it. That's why we have to go there.
Yeah.
Yeah, if we go there, at least if there's a dust storm, at least we got some cool, video opportunities of seeing the dust storm go past. Yeah, so we're actually nearing the end of our program. So kind of this will be the nice time for Q&A. So if y'all have any questions, this is the time to drop them into the chat.
Get in the comments.
Yeah, drop the comments. Also give the rating if you want.
Smash that subscribe.
Yeah, the like button, subscribe, not to just to us, but to Lowell as well. Yeah, though there was a thing that came up about kind of with Mythos, so seems already got answered, but might be a fun thing for y'all about if there's any connections between like Mars and like Taurus or Mars and Aries, kind of like similarities between like Aries, God of War name, and Aries, like the ram.
I don't.
I think they're different.
Different Aries.
Yeah.
Okay.
Yeah. Yeah.
That's
And
good.
you mentioned Aries, is the Aries. So Aries is the Roman god, is that right? Or the Greek? Maybe it's the Greek.
Yeah.
But then, like you're saying, Antares, the star in Scorpio is kind of red color, and so Antares means not Mars, essentially. So they, it can look a little bit the same because the reddish color a little bit.
And I guess we're talking about fun, weird Mars mythology. So like the days of the week are named. Like there's Sunday and Moon Day, right? And then the rest of them were Roman planets for a long time. Tuesday specifically was Mars, and then but English is a Germanic language, so we went with the Norse route, and we went with the Norse equivalent of Mars, which is Tyr, who was the god of war and also like agriculture, because Mars was the god of war, but also agriculture, and they think it was conflated with another god to make it like the god of like crazy rage war. Like that was like a later addition to the Mars mythos. But originally Mars was like, farming, and also like if we have to, what is it, like swords to plowshares or whatever, the other way around, was kind of like what Mars was all about. And so was Tyr. And so that's how we get what is it? Tizendog, right? Tuesday. Yeah.
Well, that's so cool. Any other cool Mars missiles you want to share? Well, questions get submitted.
I think we like whimsy and we like mythology and we like stories. So Mars, like Phobos and Deimos, was it fear and panic?
Fear and panic,
yeah.
or something like that.
It's
yeah.
cool. Like the god of war rides across the sky, followed by fear and panic. We love that kind of stuff. And to like be able to like look up at the sky and imagine these stories and things, especially things that cross the sky quickly, like Mercury and Mars, and Venus. We get a lot of fun mythology with them, right? Like martial law and martial arts are like the arts of war and the arts of, and the law of war and whatnot. And then things from Mars, Martian, the Martian moon, the Martian manhunter, Martian whatever. We get all this kind of stuff. Love it.
So many cool stories. Yeah, I actually didn't know that. Like, I consider myself like a bit of a geek when it comes to like Greek mythology and such, but I actually didn't know that Ares was more of a peaceful man before he decided to go into war and such.
It was mixed together with another god around that time, from like Rome, right? And so like when when Rome and kind of like that like southern Italy kind of area, you get these like gods of war and agriculture and things. And then when when the Greeks kind of did their thing, you started to combine them and you conflate these stories in really weird and cool ways. Like half of the mythology of the night sky is like, hey, here's two stories that are very different. Let's smush them together. And then now we have a chariot pulled by goats, or whatever, Oh, and Saturday. Oh, never mind. I'm just going on a mythology rant.
Oh, I'm guessing Saturdays with Saturn.
Saturday means laundry day.
Oh.
Well, you're whimsical, yeah.
It's kind of fun. The rest of them are the Greek or the Norse equivalents of the Roman gods that were those days of the week that were being honored on them. But Tyr.
That's cool. Didn't know that.
it's interesting because the mythology, it really, space is part of our everyday life. And it goes back, people, they didn't have TV or anything, they look up at the sky. And so much of life revolved around what was happening with the planets and the moon and the sun. And so names of the week, names of months, times we use is all astronomy based. And so when we talk about this stuff, AM and PM is astronomy. Again, the days of the week, there's so much of it that we take for granted, but it's all based on astronomy.
Yeah, like from the cultural to even like Mars sciences, like the camera on phones was astronomy related. Like we wouldn't really have satellites if we didn't want to go into space and in between.
The night sky was the first book, like constellations and the planets and the mythologies and things like that. You just look up at the night sky to remember which story you want to tell around your campfire that night.
Yeah.
Okay, so John, you have to tell us what AM and PM mean.
I don't know. That's a Kevin.
It's
Do you know, Kevin?
so there's anywhere you're standing on Earth, if you connect north and south with a line overhead, that's the meridian. So wherever you're standing is a meridian. So AM is anti-meridian when the sun is before the meridian. It's at the meridian at noon, and then PM is post-meridian after the meridian. And so it just has to do with the position of the sun. And it's like, again, you hear after midnight and post-midnight, I think I've heard, but it has to do with the meridian. Again, astronomy-based everyday stuff in our life we don't even think about.
Snaps for astronomy.
Yay for astronomy. People are doing astronomy and not even knowing it.
Yes.
So yeah, it seems there haven't really been many other questions submitted. So yeah, we're kind of at the end of our program. Kevin, John, wanted to thank you so much for joining us. This was really cool, and I definitely learned a lot about Mars and such, and about AM and PM. Did not know that in the slightest.
Well, thanks for
and also, oh yeah, of course. And we're really happy y'all were able to join on in, and that we were able to do this. Yeah,
so we love partnering with you guys, and the more of these, the better, because we're all trying to inspire people about space, and to do it together is so much fun.
This is fun.
Yeah, definitely.
And so,
even like astronomy, it's like we kind of have to work together to get further.
Yeah. And so all you people who are watching who are Lowell Observatory followers, come see us. And all you people who are watching who are McDonald Observatory followers, go see Lowell, and everyone will be happy.
Yeah. And if you by chance don't know, so for those of you who are Lowell watchers, also McDonald Observatory, we're out in far west Texas. Texas is a very big place, but we're very, very out in the far west.
We're on the Arizona side.
Yeah, Arizona side. We're like on the border of the Mountain Time Zone. And for those of you from McDonald Observatory who want to go check out Lowell, they're out in Flagstaff, Arizona.
We're a mile west of downtown. So you drive into town, there's this big birthday cake building on the side of the hill. It's so easy to find. And it's really neat to compare the two because, we both have telescope domes, but you guys are out there where it's ultra dark, and your research telescopes are up on the hill right behind your heads. In fact, there, and they're different, and they're both so fabulous. I think. I was going to ask, are you guys members of ASTC, Association of Science and Technology Centers?
Yes.
Yep, we are.
Membership allows you to go to either place. It's part of your membership. So if you got your Aztec membership at McDonald, you can use it here and other science centers around the country.
Yeah, if you just want to do a road trip through, Western United States, make sure to drop by both of the observatories. And if you want to even go back through, so you can just, I should compare and contrast again. And
yeah, come visit, come hang out.
Yeah, and also Lowell has like awesome YouTube channel as well, and YouTube videos, and also really cool podcasts that y'all should definitely check out. Also, like they have really awesome social media as well, and we hope to do more partnerships like this in the future. And so thank you so much for joining us today. Yeah, so you can find us, both of us, on social media pages. For McDonald is Facebook, Instagram, and Twitter. For Lowell, I'm assuming the same social media pages.
Yep.
All right. Yeah. Assumption. Yeah. Then also this stream will be saved onto here. So if you have any friends or family that didn't get to see them, feel free to forward them a link.
Yep.
Yeah. And we hope y'all enjoyed. Thank you so much for joining us, both to those watching and to Lowell.
Thanks,
Good night.
nerds. Bye, nerds.
Night.